Okay, so in this video I want to discuss the use of inductive charging or wireless charging. And now to do that, what I want to use is these two large receiver and transmitter modules which I was able to pick up online. But before we actually go into the nitty-gritty of integrating these into products that don't already have wireless charging and show you how that works, what I'd like to do is talk about some products that already have wireless charging built in. Now, it's important to note, first of all, that wireless charging has been around since the late 19th century, I suppose. But it only has really come into use in the last 15-20 years in, let's say, commercial products. One good example of the earliest adopters of it would be for the use of electric toothbrushes, where you have your transmitter module, which usually sits in a base like this. And then you have your receiver module, which sits in the base of your toothbrush. Now, it was fantastic for this application because wireless charging is not as it's not as efficient really as, to the wall itself, direct charging. I think direct charging is somewhere up to 85% effective. So like energy lost through heat and wherever else, what other wastes, it's 85%. But when you're going for wireless, it's 50 and less percent. So a lot of power is being wasted through heat and other issues with that particular process. But for the ease of use, it's very handy just to be able to plug this in after washing your teeth twice a day or 3 times a day, and it slowly charges till the next time you need it. Now, it's starting to be integrated into more products, so we can start seeing it being integrated in things such as phones and other little products of late. A good example of it being used outside of a phone would be these wireless earbuds. So I have 2 different versions here, a fake and a real version of the Apple AirPod Pros. This here is our fake version, and you can see how inside our fake version we have our receiving coil, as you can see here. And we can also see how it basically feeds that power to this board, which regulates the power for the charging of the battery, which is sandwiched in here at the back. Now, if we have a look at our real Apple AirPods, which we have here, which are a bit better packaged, but all really the same things are in it, we can see that we have at the very back here, might be hard to see, covered up with a bit of black plastic is actually the magnetic coils, or the actual receiver coil, and it's up against the back plastic right inside there. And we can see how that power then is fed to the motherboard, which is sandwiched in between these 2 lithium-ion batteries, similar enough to the fake product. Now, you can also see this in modern day iPhones as well as Android devices, where they have built in these coils into the rear back of their phone. One thing you'll notice though is that on certain phones, on phones that use this technology, they have to be very careful about the material used in between the coils, so that that the coils can actually transfer that power effectively. So let's have a quick look now again at our 2 modules, which you can see here and here. What I would like to do with these 2 modules to show you how they work is, first of all, I'd like to show you out here working with a power source to show you how the power actually transfers between transmitter and the receiver. So to do that, what I'm going to do is I'm going to pull over my power supply. I know these units take 12 volts. So what I can do is I can give 12 volts to my transmitter, put in positive to positive here, like so, negative to negative, like so. And then what I can do is I can turn on my power here, and as you can see from the screen, I have nearly 12 volts, so 11.6 volts, and you can see that I'm drawing a few amps. Okay, so now to see if this is all working, we can bring in our variable power supply. We'll set it to voltage DC because that is the power that's coming in. We can flip this over. It has no indication that we are receiving power to this unit. So what I can do is I can go over here and I can see where it connects and see if I'm getting my power. Perfect, 11.65 volts. So now what I can do is I can put my inductive coil over top, and what should happen is that there'll be a little LED here on this end, right there, if we can get it to focus in, that should light up. There we go. Now you can see if I move it slowly over to the side, that light will turn off, so it no longer works. Two coils aren't directly above each other. I slowly move back, it works again. Also, if I vary the height of it away, it stops working, and as I slowly come closer and closer and closer, it works. Now, just to show you, these actually don't have to touch for them to work. So if I keep a small bit of a gap between them, you can see it's still working. But eventually, when I move them far and further away from each other, they stop working. If I move it back in towards each other again, they should work fine again, like so. Okay, so now that we know the unit is working, what we can do is we can integrate it into a product and show you how that wireless charging can be used. So to do that, what we're going to do is we're going to take apart this little LED floodlight. You can see we have an LED matrix here. There's multiple LEDs all in a matrix. And we'll just take it apart and we'll wire it in so that our charging port here, the plus and the negative of this USB-C charging port, is actually receiving power from our receiving coil, okay, or module. So what we'll do is we'll just take this apart and we'll wire it up. Okay, so once we open up this unit, because it's a waterproof unit, there is going to be a seal integrated into it. Okay, so I need to lift this up. So we can see that there's a nice rubber seal inside here between the two clamshells. And we can also see that we have a nice big heat sink here for our 5x5 matrix to dissipate the heat. We can actually disconnect that here, and we can remove that LED matrix and just deal with our actual motherboard, or our board itself. And our battery, which we can see is a 3.7 volts, 4,500 milliamp. Now, interestingly enough, that's around the same size as a typical phone battery, but obviously in this cylindrical cell rather than a flat rectangular cell, similar to something like this, which you'd find in a phone. Usually it's a bit longer, a bit bigger. Like I was looking at the products there earlier, you can see that, you know, for these kind of like wireless earbuds, they tend to have these smaller cells. Okay, so what we can do now is we can just take this apart also. They were nice enough to let us disconnect the battery quite easily and bring out the battery cell. And now I just have two screws here which are holding in that main board. Okay, so this is the main board. You can see we have our USB-A, which is for charging other devices, so you can use this floodlight as basically a battery bank. We have the switch, which is activated by this little rubber membrane here, as you can see. It's like a little rubber membrane that you can press down and actually actuates the switch. And we have our LED light, which indicates if it is on or if it's charging, which is going to be important later. Now, one thing I want us to note is that we are going to want to not wire directly into the battery, because there's obviously battery management system in this board itself, which ensures the battery doesn't get overcharged. So what we can do is actually just pretend that we are USB-C connector coming in, but only supplying 2 amps rather than the 5 volts and whatever amps are usually typically coming in on a USB-C charger, which varies depending on the charger. So what we can do is use our plus and minus. So plus and minus, we can see the back connections here and here, and just wire it directly up into that. So it will think that it's coming directly from this port. Now, if we want to indicate which ones are plus and minus, you can actually see here that this side, left-hand side, is plus. This side over here, if we can see, is actually minus. Okay, so that means on the far side here, that's going to be our black, and this side here is going to be our red for our positive. Okay, so I'm just going to wire this up and I'm going to come back to assemble and we'll test the wireless charging. Okay, so now that we have our receiver coil all wired up, as you can see here, like discussed previously, what we've done is we've used our USB-C port, which you can see here, and we've used the positive and the negative terminals, which I've just accessed them from the back, and just wired directly in this this receiver coil. Now, what should happen here is that the device still thinks that a USB-C charger has been plugged in and the power is just being transferred through that. But what will actually be happening is it'll be transferring through our inductive coils, and the power will be fed at a slower rate. This is actually rated for 5 volts 2 amps, so it'll charge a lot faster than the typical USB-C charger. Now, USB chargers do vary, but you know, for the different standards, USB-C 2 amps is quite slow. So what we can do now is we can start putting things back together. Now, I'm not fully going to put things back together because there's not quite a lot of space inside this housing to host this additional board and this coil. As well as that, the coil cannot lie flat. There's a bit too much space because of the way the injection molding was done here. So what we can do, if we wanted to, we could drill a hole in the side of this and we could basically just feed out our 2 wires and then just basically tape on our wireless charging, or even make a 3D housing of some sort to host it. But for now, just to prove concept, what we can do is we can just put this back together. Okay, so now what we can do is we can check if it actually runs still off of the battery unit itself. So if I click this, ideal, we can see our green light is on to show that it is on, and we can see our actual LED matrix is also turned on. Now, if I cycle through the different versions on and off, I can get to the off state again. But now what we're going to do is we're going to try to start to charge it, not through our USB-C port, but using our I suppose our inductive coupling technique by using our 2 coils. Now, what should happen is this light here should start flashing red to indicate that it is charging. I'm just going to leave that up here like this, and what I'm going to do is I'm going to get my transmitter unit and I'm going to get my variable power supply. I think I already have it set up for 12 volts. So let's find out. Ideal, that's close enough, 11.6.8. Now our amps won't show till I actually connect it up. Let's go red to red, so positive to positive and negative to negative. Ideal. Okay, so I can see my amperage is starting to go up. Now, what I'm going to do, without letting these touch, is I'm going to just not place the coil on top of the other coil, but I'm just going to hover it above it, slowly come down along to see until it transfers that power. Excellent. So you can see there the flashing red indicates that now it is charging through the inductive coils. I'm actually not touching these coils off of each other. What I can do is I can turn to the side now and show you a side profile so you can see that I'm not touching them off each other. Like so. There's a gap between and the charging is taking place.